Hello everyone. Today we are going to learn about biological oxygen demand and chemical oxygen demand. So starting with biological oxygen demand. So let us understand by using this figure as an example. So let us consider that this figure consists of polluted water, and obviously in polluted water there are microorganisms, and we also need to think that the polluted water also have organic matter as a waste. So, biological oxygen demand is the process in which microorganisms consume oxygen to decompose organic matter. So, so we can define biological oxygen demand as in a fixed volume of polluted water, microorganisms consume oxygen 5 days at 20 degrees centigrade is called biological oxygen demand. So microorganisms decompose organic matter. To decompose organic matter, microorganisms need oxygen. Hence, they consume oxygen. This process is called biological oxygen demand. So, it is a simple process in which microorganisms decompose organic matter by consuming oxygen. So now moving on to next, we have how can we determine BOD, biological oxygen demand. So these are the necessary conditions, or these are the necessary things that need to be met to determine BOD. So first and foremost thing we need is we need to fix the volume of polluted water. So for example, if we have fixed the volume of polluted water as 2 liter, then we can determine BOD. Now moving on to the next, we also need to dissolve oxygen in the polluted water, so it becomes saturated with water. As in BOD process, microorganisms consume oxygen to decompose organic matter. So we need to saturate the polluted water with oxygen. Now moving on to next, how can we calculate the oxygen saturate? How can we calculate the oxygen that is saturated with water? So to calculate the oxygen, we need to know the amount of oxygen consumed by microorganisms divided by total volume of water and multiplied with 100. Then we'll get in the percentage in percentage format. Now, yes, obviously on the condition is we need to have the fixed temperature, and the temperature is suppose if we have fixed 20 degrees centigrade, and at 20 degrees centigrade, microorganisms take at least 5 days to consume the oxygen or to decompose the organic matter. And next thing we need to know is that BOD is always measured in ppm, which stands for parts per million, because they consume oxygen in very less amount. Now moving on to next, we have this example. So we need to consider this figure as an polluted water, as a polluted water, and obviously in polluted water there is organic matter as an waste, and along with organic matter there are microorganisms. Uh, so so if we have if we consider the volume of polluted water as 2 liter, and the number of days is 5 days. So at that days, so at that much time, microorganisms consume oxygen and decompose the organic matter. So amount of oxygen dissolved is 10 gram, which means that in polluted water, we have dissolved 10 gram of oxygen and make that water saturated. So the amount of oxygen consumed by microorganisms is 9.9 gram, and no, the amount of oxygen by microorganism is 9.9 gram. So 0.1 gram oxygen is left, and that divided by total volume of water times 10 to the power 6, which will convert it into ppm, so parts per million. Now moving on to next, we need to know the key points of BOD. So, definition: the amount of oxygen needed by microorganisms to break down organic material present in a given water at a certain temperature over a certain time period, right? So, so we need microorganisms and to break down the organic material. So, in given water sample, so we consider water sample as 2 liter at certain temperature. We consider temperature at 20 degrees centigrade over a specific time period, and we take time period as 5 days, right? So BOD of clean water has BOD value less than 5 ppm. So we need to know that clean water has BOD less than 5 ppm. Now polluted river water has BOD of 17 ppm or more. Polluted water has BOD more than 17 or more, and sewage water has BOD range between 100 to 140. So these are the key points that we need to know of BOD. Now moving on to next, we have COD, which stands for chemical oxygen demand. So So in chemical oxygen demand, we need to know that polluted water contains both organic as well as inorganic compound, right? So organic, if there is organic compound, then we need to go for BOD because microorganisms consume oxygen and decompose the organic matter, right? Now, so in COD, there are both organic as well as inorganic compound. So we need to oxidize organic and inorganic compound in the COD process in chemical oxygen demand process. So so it is the process that amount of it is the process in which amount of oxygen is needed is produced by chemical. So strong oxidizing agent is used. So amount of oxygen needed is produced by chemical. So strong oxidizing agent is used, right? So chemical oxygen demand is a measure of the capacity of waste water to consume oxygen during oxidizing agent, usually acidified potassium dichromate. So chemical oxygen demand process is a process in which polluted water contains both organic as well as inorganic compound, and we need oxygen, and oxygen needed to oxidize organic and inorganic compound is produced by strong oxidizing agent. So in this example, we have used potassium dichromate, that is K2Cr2O7, as an strong oxidizing agent, which when reacted with H2SO4 gives when reacted with H2SO4 gives K2SO4 plus Cr2SO4O3 plus 4H2O plus 3O. This nascent oxygen which is produced helps to decompose or helps to react with the organic and inorganic compound. It simply oxidizes the organic and inorganic compound. Now moving on to next, we have the final topic, which is the comparison between BOD and COD. So biological oxygen demand and chemical oxygen demand (COD). So biological oxygen demand is the amount of oxygen required for bacteria while decomposing organic matter under aerobic condition, where oxygen is available. So biological oxygen demand is the process in which microorganisms or bacteria consume or require oxygen while decomposing the organic matter under aerobic condition, which means where there is excess amount of oxygen. Now moving on to next, in COD, the amount of oxygen is produced. The amount of oxygen is produced by the uh, strong oxidizing agents such as potassium dichromate potassium dichromate, which helps in the oxidation of organic and inorganic matter in water. And now moving on to next, we have BOD, that is biological oxygen demand is slow method, as it requires 5 days to determine, as the microorganisms consume slowly or they just take too much time, right? Now in COD, it is a fast method. So if we do the COD process in lab, it generally takes 2 to 3 hours to determine the COD. Okay, 5 days are taken for determination, few days are taken for determination, and that few days are also mainly, they are just in 2 to 3 hours. So BOD is performed at lower temperature, and COD is performed at higher temperature. The value is low than the value of BOD is low than of COD, as O2 is low, right? O2 is lower because microorganisms consumes less oxygen, and the value of COD is greater than that of BOD. So these are the things that we need to keep in mind while we have to compare between BOD and COD. So this was all for today. This was the difference between BOD and the basic concepts of BOD and COD. Now, thank you very much. And we'll move on to next topic very soon. I'll upload new videos. So thank you very much. Thank you.